So this course is focused on practical knowledge. After all this theory, let's go and inspect the memory layout of an actual binary. Right here I have a program called stack and heap, and when I run it, it outputs some number. So let's open it in a debugger to see what's going on there. So first we can inspect our source code. This is our first encounter with Rust syntax, but the code is almost exactly the same as the pseudocode from the previous examples. We can see that we have a main function. It creates a local variable a that is an integer and then passes it to the stack only function. The stack only function accepts an integer, which is of type i32. This is just a 32-bit integer. It creates another local variable on the stack and then calls the stack and heap function, which also creates a local variable and then creates this box, passing it a number. So box is a type of smart pointer in Rust. And now we'll see exactly how it works, but it will just go ahead, allocate some memory on the heap for us, and then when it goes out of scope, it will make sure to go and free that memory. So if we put a breakpoint on our stack only function and another breakpoint on our stack and heap function, and then we can actually run our code and see what will happen. So here on top, we see our source code and we see exactly where our breakpoint is. Where are we at the moment? Right now, what we can do is we can inspect our stack. And we see two stack frames here. So the top stack frame is the stack frame for the stack only function, which is the one that's being executed at the moment. And it is on top of the stack frame for the main function, the one that coded. So this is exactly the same as the previous demos that we had. Nothing surprising so far. So we can also inspect our local variables, and currently we have no local variables here because, as we said, the function only has access to its stack frame, so it doesn't have access to the local variables from the previous functions, for example. But it has an argument, like we can see that we have our b and it is equal to 2, so this is the argument that the function was called with, that was passed from the main function. So now if we step one line and then we check our locals again, we can see that our integer c was stored to the stack and it has the value 3. That's exactly what we would expect to happen. Now let's jump to the stack and heap function. Again, if we inspect our stack, we see that we have a new frame. So the top stack frame is for the stack and heap function, which is on top of the stack only function, which is on top of the stack frame for the main function. If we check, we have no arguments and we have no locals so far. So that's a brand new stack frame that currently stores absolutely nothing. So again, we can step one line, we can check our locals and we can see our integer d that's stored there. And now this is where the interesting part comes. If we step another line, we have allocated some memory on the heap. So if we check our locals, we can see that we have this e and it's equal to this big number. So this is our address on the heap. This is where our value 7 lives. So we can actually go ahead and read whatever is at this address and we can see that we get the number 7. We can actually format this as a digit, put the address here, and yeah, we can see the value 7. So when we dereference this address, we get the value that we stored there. That's great. And now when we actually exit the stack and heap function, if we try to read this address again, we see that now it's equal to 0. The reason for this is that the smart pointer, which is the box in this case, went out of scope when the function finished, and then the box made sure to go ahead and free the memory it was pointing to. So right now, if we check our stack frames, we can see that the top stack frame is the stack only one. So the stack and heap one was deallocated. And if we continue executing, we're back in the main function, and now we see that our top stack frame is the main one, and below it is some language function that actually started our process. We don't care about that. But yeah, the stack frames for the stack and heap and the stack only have been released. And then we can just continue with our function, and our program exits outputting the sum of all these numbers that we had. So this is pretty much what happens when you run a program.